Okay, so today what we're going to do is we're going to talk about another type of function. These are logarithmic functions. Now, logarithmic functions, we talked a little bit about how you can change a logarithm into an exponent and an exponent into a logarithm last time. So what we're going to do today is we're going to look at how you can evaluate some of these and solve some of these problems involving logarithms. As you can well imagine, if you'll remember our discussion, logarithms are just another way of writing exponents. So the rules that you're going to use for working with these are many of the same rules that you use for working with exponents. As a matter of fact, most of the time you're simply going to change the logarithm into an exponent and then work from that. Okay, so a couple things we need to talk about. We need a little bit of a summary so we can remember these things, okay? So let's start with just what I was talking about. So remember that logs are exponents. So they behave the same way. And usually, okay, changing them to an exponent is the easier choice and makes it easier for you to solve. So keep that in mind. Okay? Also remember a couple of things too. Depending on what you're solving for, then you're going to do a little bit different type of activities. So the first thing remember, if x, so remember that you're solving for x, just like any other equation there. If x is the base or the quantity, remember that we had our logarithm, we had a base and the quantity are on one side of the equal symbol, and then after the equal symbol is the exponent, right? If that's the case, then simply solve like the exponent equations. Right? If that's the case, and we'll refresh your memory about how to do that in just a second too. If graphing, okay, solve like an exponent. Okay, and again, we'll talk about each of those skills and what to do, but I just want to keep it in mind that remember you're solving these things like exponents for the logarithmic functions to make your life easier by thinking about what you're doing. All right, to solve these logarithmic equations, let's talk about the steps of the process. Okay, first, okay, if x is the base or the quantity, and again remember that means that they're on that left hand side of the equation with the word log, right? If the base if the x is the base or the quantity, okay, then change to an exponent, just so you can get rid of the log word, right? Change to an exponent and then solve for x by just doing the opposite. Get the x completely on one side by itself, then divide, multiply, whatever you have to do to get that x completely alone, right? Then you'll have your x equals something. Okay? Now, if x is in the exponent, then it's a little different. Now remember, in this case, if x is in the exponent, what you want to do is change the base. Again, we're going to work with it as exponents. So first change the logarithm into exponential notation, and then change the base and set the exponents equal to each other. right? Remember we did that in the past. So what you're going to see here is a lot of repetition from what we learned. We've learned how to do it with exponents. Now we're going to learn how to change those logarithms into exponents and do it some more. So this particular chapter looks very daunting when you first look at it, but it's really you're doing it the same thing over and over again. Okay? Now here, there is a special case. And unfortunately, you're just going to have to remember it, but when you do have it, it makes your life really easy. If the log is in the exponent, and I'll show you an example of what that looks like, okay, and the bases are the same, now they're not going to mess with you, they're going to be the same, okay, then the answer, x, is simply the quantity of the log. Okay, so let's look at an example of what I mean. Say we have x equals 2 raised to the log base 2 of 9. Okay? Alright. So, anytime we have this log raised to something raised to that log, the answer is just going to be whatever that argument is. So 9. Okay? You don't have to worry about solving it. That's just going to be your answer. And you'll see that in an example as we move forward with these. Okay? Alright. Now let's talk a little bit about graphing these. So we talk about graphing logarithmic equations or logarithmic functions. When we're talking about these, remember that they're just exponents. So your first step is to change it to an exponent. Okay? Your second step is to think about the shape. Remember that if the base, a, is greater than 1, that means it's going to be going up like that, right? And if the base is between 0 and 1, fraction or decimal, that means that it's going to be doing that downward thing. Okay? And also remember that all of these have a vertical asymptote at x equals 0. They can't cross 0, right? They just get closer and closer and closer to it, unless, and this is a big unless, unless there is a horizontal shift. Because if you have a horizontal shift, then you're changing the focus, you're changing the position of the graph, and so it can move back and forth. But it still gets a horizontal asymptote, vertical asymptote. It gets a vertical asymptote at that number. So say it was shifted to the left 2, then so -2 would be your vertical asymptote. And the thing just gets closer and closer and closer to -2. So whatever number your shift is, your horizontal shift. Okay? And we'll look at an example of that so you can make sure you understand. Now, all of that is stuff that we've done before, except for those two special cases. What's new for this particular section are some properties of logarithms that you will be forced to remember. You're going to use them later, so make sure you understand them. They're pretty easy because they actually come from properties of exponents. And so I'm going to use those to demonstrate them. Okay? The first one is the product rule. Now I'm going to give you the exponent first, and then I'm going to show you what it does for a log. Okay? If it were an exponent, remember that x squared times x to the third is the same as taking the two exponents and adding them together. Remember that? Well, that same property can be done with logarithms. So, say for example, okay, keep that addition thing in mind. If you have log base a of 3x, that's the same as, remember that 3x is the same as 3 times x. So in other words, it's a product, right? Well, remember when you had the product of exponents, you added them. So that's the same as log base a of 3 plus log base a of x. All right, so you just get each quantity gets its own logarithm, and the two logarithms are simply added together because it was a product. Okay. Quotient. Remember, quotient means that you're dividing. Remember, when you have exponents, we'll demonstrate with exponents first. If you have some x to the 5th divided by some x to the 3rd, that's the same as x to the 5 minus 3, right? So, in other words, when it's a quotient, you end up doing subtraction. And the same thing is true with the logarithms. Say we have some log base a of x to the 2nd over y to the 3rd. Now, purposely use different exponents, different bases on those, because if the bases were the same, then you could just do the division and then you don't have any division, right? But you can't divide an x by a y, so that's why this is, you'll see it like that, okay? So, since x squared over y squared means x squared divided by y squared, right? What you get is, you get two different logarithms, the logarithm of the top, but this time not plus, but minus the logarithm of the bottom. And be careful here, if you have two terms in the bottom, that's, you're subtracting both of them, so it's going to change a lot of signs when you do that. So I'll show you that in an example as well. So that's the quotient rule. And again, if you know your laws for exponents, then you see that they just translate right into the rules for logarithms. Okay, now let's look at the last one, and this is something called the power rule. Now, again, for exponents, it doesn't exactly look the same, but it's close. Watch what happens. So remember, you have some x squared raised to the 3rd power. Then what you end up doing is you end up taking that 3 times the 2, right? So you end up multiplying. Well, you're still going to multiply, but it looks a little different. So say we have some log base a of x to the r power. Okay? So do you see that our argument has an exponent on it? So what we're going to do is we're going to take that r and simply move it in front of the log, So it's the same as r times log base a of x. So it gets rid of the exponent. It puts it in front and it becomes a multiplier. Now you can see the math behind that. You don't want to, just learn it, that it goes in front. It is one of those things in mathematics that makes your life so easy as long as you learn it and understand how to do it. The y is not so important. So, all right, just move the exponent in front of the log and it becomes a multiplier. And of course, you don't have to write the multiplication, just like I've done here, the little dot. You can just put the number in front of the word log. Okay, just becomes its coefficient. All right, so that takes us through what's new in this section, but of course anything that's different also looks new, so we're going to go through and do lots of examples. Now there are 32 problems in this set, which means you're going to get a lot of practice. They're all mixed together, some graphing, some product rules, some whatever. So you're going to want to make sure that you really stay focused on these notes. So hopefully you have them written down on your own and you're not just referring back to what I've written. Make sure you take good notes and write these things down so that you can be able to refer to them later as you need them. But having to jump back and forth and do them over and over and over again and consider, stop and think about the problem. Remember, that's the best way to think of this anytime. What kind of problem are you doing? Okay? What are the steps? Or what's the process? Okay? So ask yourself those questions every time you see a problem, and that slows you down and gets your mind working on what do I need to do, because your brain is pretty remarkable and it can recognize different patterns. That's how we survive. Okay? So let's go to the homework. And see some of these things in action. Okay, so for the first sections, what they want you to do is simply answer these questions using the rules for exponents so that you understand the rules for exponents. And then you can set these, don't use a calculator, don't just put them in a calculator, but you can solve these by setting them equal to exponents and just using x to represent your unknown. For example, if you have log base 2 of 16, okay, we want to know what that is. Okay, so there we go. What it literally means is, what exponent would you put on a 2 to get 16? So we're looking for an exponent here. So if we change this to exponential notation, it would be 2 to the x is equal to 16. Alright, now notice that our x is in the exponent, so that means we have to use the same base. So it's going to be 2 to the x equals, now we need the bases to be the same, so 16 is 2 times itself over and over again, right? 2 times 2 is 4, times another 2 is 8, times another 2 is 16, so it's 2 to the 4th. And then you simply set the exponents equal to each other, and that gives you your answer. We didn't have any solving to do, because once we set the exponents equal to each other, we were done, right? So we can go through and do all of these that exact same way. It's good practice for you for working some of these out. Now, I'm not going to do all of them, but we'll pop through a few of them that I think may give you some questions. So, for example, look at E, where you have log base E of something. Let's do that one, because I want to make sure we understand how that works. It doesn't matter what the base is. You might not know what log base E is. E is a constant. It doesn't make the slightest bit of difference to you right now. All you need to know is that we are solving. Okay? So, think about this as an exponent. Okay? It would be E to what power would equal 1 over E squared. So what we want to do is, since our x is in the exponent, we want to change the base here so that we get an exponent that so that we can then set the exponents equal to each other. And so think about your laws of exponents. We get an e squared, right? And we started off with plain old e. So we know that we need an exponent of 2, but it's 1 over that. And the only thing that causes that to happen is to have a negative. So it's e to the x is equal to e to the negative 2 power, right? Because remember, we want to turn our e in, we already have the exponent we need, but because we had the 1 above it, that means that we were talking about a reciprocal here. So the only thing that can do that is a negative, and then it's simply a matter of putting the exponents equal to each other And so we get x equals -2. Okay, so these are just like those others that we've done. You just have to think about that change of base part. Okay, and if you know your laws of exponents, the base change is pretty darn easy if you know them. Okay, let's look at the next one. Okay, same thing. Just be able to just look at what exponents you have. Put them together. Be careful there with the 27. Log base 3 of 27 to the 3 halves, right? We're looking for the exponent, so just set the exponents equal to each other. It already has an exponent, but watch out for that base. Now, convert to an exponential notation. Converting from exponential notation to logarithmic notation, is very easy, as long as you remember that it's log of a of x equals n. Who cares? All right, where a is the base, x is the quantity. In other words, what would you get if you raised it to the exponent? And then n, I've used n here, is the exponent. So we just move things around. There are a lot of these in this section. You're going to get really good at this, but make sure you take it slowly and carefully so you'll know which piece goes where. Okay? So let's look at this particular one. The base is the thing that follows the logarithm. So the base is the 2. The quantity is the thing that is right after that, so that's the 4. And the exponent is the thing that follows the equal symbol, so it's a 2. Okay? Literally, this means what exponent would you put on the 2 to get a 4? Well, 2 to the second is 4, right? Okay? So you would just type it in as, so they just want that part of it right there. So the completed answer would be 2 to the second equals 4. All right? So remember, when you change it, the base and exponent will go together, and then it will equal the quantity. So you're just changing the directions of things, moving things around. Okay? Let's see what they do to us next. This one we're going to convert into logarithmic form. So remember, we have a base. Our base this time is 3. It has an exponent on it, which is 3, and then those two multiplied out would give you the quantity 27. So it's log, then we need a base. Our base in this case is 3. Then we need our quantity on this side. And then finally our exponent goes on this side. Okay? And if you look, they already have the log and then the base put in there, so you just need to put the 27 equals the 3 on that side. Be careful about where things go. Also, I hate it that they keep on using the same base and exponent that they look alike. That's very unusual. They are usually not the same number. Okay? Let's look at a couple more of those, just so we can get ourselves geared up. Okay. Here's one where we're actually going to be solving the logarithmic equation. So, give us some practice with that. Remember, logarithms are just exponents, and we're going to solve it based on where the x is. This time, the x is right there. So that x is the base. Okay? So remember, a while ago I told you that if it's the base or the quantity, then all you do is just change it to an exponent and then solve. Okay? So our base is x raised to the third power should be 343 over 216. Now my x is almost completely by itself. The only thing that's over there with the x is the exponent of 3. And remember, to get rid of an exponent, you use a root. And whatever root whatever exponent you have, that's the root that you take. Now remember, that can only happen when that x is already completely by itself. You have the x to some power equals a number, which is what's going to happen to you in these always, because those are all the pieces that you have, right? So we will take the cube root of this side and the cube root of the other side. Remember, what you do to one side, you do exactly the same to the other. Over here, these two things are opposites, so they're just going to eliminate each other and give you x to the third. On the other side, however, we need to find out what the cube root of each one of these numbers is. And you can do that using your calculator, or some of them are so common that you'll know what those answers are. Okay. But if you don't, again, just take the cube root using your calculator. The cube root of 347, in other words, what number times itself 3 times is 343, I'm sorry, I said that wrong, is 7. The cube root of 216, that 216 is 6 times 6 times 6. Now my x is completely by itself, so there's my completed answer. Okay, so you see the mathematics behind this is not very difficult. You just have to remember how to process it, how to make this process work. Okay? Let's see. Okay, this one looks worse. It's not. It's just another logarithmic equation. So let's take a look at it real quickly. So the base is 36. The exponent is, remember, on the other side. And the quantity is the ninth root of the square, the ninth root of 6. So what we have to do then is we want this, in order to solve this, we need these bases to be the same, right? So the bases need to be the same. A couple things are happening here. We have a base of this radical is 6, but this is a 36. So I need to change both sides. I can't leave this radical, and I don't want this to be a 36. But remember that 36 is simply 6 squared, right? So I could rewrite 36 as 6 squared, but don't forget, we also still have that x up there. So that becomes 6 to the 2x. Okay? On this side, the ninth root of 6 is 6 to the 1/9 power. Remember, anytime you can change a root to any root to an exponent by using a fractional exponent, then it's just a matter of setting the exponents equal to each other and solving. Alright, so divide both sides by 2. And remember, that's the same, becomes the same as 1 over 9 times 2 over 1. Invert and multiply, right? 1 over 9 divided by 2. Or you can put it in your calculator and just work it out. 2 over 1, okay? Times 1/2. Put it in your calculator because you can't listen to me, can you? So it's 1 over 9 times 1 over 2, which is 1 over 18. Okay? So, gives you your final answer. Just invert and multiply. Okay. Now, again, make sure that these bases are the same, though. Be very careful about that. You may have to change one of them or both of them. Here's when we're given a graph, and we're going to sketch the graph of the particular function and then give its domain and range. So let's look at, and you'll notice that they're multiple choice. That makes our life a little easier. But remember that when we're graphing these, and f of x is the same as saying y, so y is equal to log base 2 of x, right? Which is the same as saying the base is 2, the exponent is y, and that gives you the quantity x. And we've graphed this before. If that base is bigger than 1, then you know that it's doing this business. It's going up, right? Remember the basic shape of the graph. So if you look at these, Okay, this one's not doing the right thing. Oops. Okay, this one's not doing the right thing. It's going down. But this one is, right? And then finally, this one is not. So, process of elimination gave us the answer this time. Just by knowing the right shape, oops, would help if I clicked on the right one. Click on C. Just by knowing the right shape, we're able to choose the correct graph. Okay? So knowing those shapes is incredibly helpful. Now, if you didn't know the correct shape, you could still find it by simply plotting some points. But remember that since the exponent is in the y is in the exponent's position, make sure you choose y values and then get x values, because it's easier to choose y values. And sometimes you're going to have to. Oh, sorry, forgotten the domain and range part. The domain, if you remember, that these can never cross 0, right? So the domain of these is always going to be the same. I'll just click on completed answer, as it won't matter. It's always going to go from 0 to positive infinity, and the range, these things always go down forever and up forever. So the domain and range is going to stay the same unless you have a shift, right? Remember, that makes a difference in the graph when you have a shift. And we'll see one of those that has a shift in a bit. Okay, here we go. Log of 1/2 to the x power. Remember, just change it to an exponent. So, and change f of x equal to y. The log base 1/2 of x becomes, in exponential notation, that's the base, y is the exponent, and x is the quantity. So we know that our base is 1/2. So that's the one where it's smaller than 1. So that means it's not going to be going up like that. Instead, it's going to be going down like this, right? Not so sharp as I have it. Okay, so going to be going down like that. So we can eliminate all but this. And because there is no shift, the domain and range are the same. No matter which direction it's pointing, the domain and range are going to be the same for them, unless there is a shift. Okay? All right. So, just like exponents, you should be pretty happy here. All right, here's some of those properties where they're talking about the properties of logarithms. Remember that there are 3 properties. There's a product, a quotient, and the power. And if you look at this one has 2 different properties. So let's look at our argument. Our quantity. I was thinking radicals. It's 3x over 2, which is the same thing as 3 times x divided by 2. So we have a product and we have a quotient. So that's going to be log base 10 of 3. Right? We're taking care of this product in the top first, so that means that we're going to get addition. And log base 10 of x. And then we're going to take care of this quotient, so that means minus log base 10 of 2. And so that long part is your answer. And yeah, you have to type in the whole thing. Sorry about that. Of course, I won't be typing it in, y'all will. Sorry. Okay. Here's one where we're just changing it back, and because it's subtraction, that means you're going to be turning it into a quotient, but look carefully because there are multipliers in front. And remember, those multipliers in front mean that your original logarithm had exponents. Right? That's the power rule. So you've got to make sure you take care of those as well. So the subtraction means that we're dividing. So get your base together. it's still going to be log base 4, right? And then just look at the pieces. The first piece, the quantity is an x, but there's a little multiplier out in front of the log of 5. That means that that was an x to the 5th. Then we have a subtraction. That means that our argument was divided, and that's y, but it had a multiplier out front that I've covered up, but if you look at it, it's 6. Don't think negative 6. Minus is the fraction bar. That's where we got this fraction bar. So it's just 6, and there's your completed answer, right? So if you know the properties, it's easy to change them back. The key here with logarithms and exponents is to make sure you're getting the right thing in the right place, and that's going to be your biggest challenge. Okay? Just going to go back to showing the completed problem so you can see what they look like all typed in. Write in logarithmic form, so you're just going to move things around so that you put the log and the base in the right place. Sometimes, for some of you, it's going to be much easier if you write out the pieces. Some of you are going to take to it a little faster. That's true of everything. But if you write out the pieces, then you are a lot more likely to get them in the right place. And please remember that those aren't always going to be the same. I don't know why they do that to you so much. So it's log, base of 5, quantity is 3125, exponent is 5. Okay? Another one, convert to exponential notation. You're just going to move the quantity and the exponent and the base around. Right? You see your completed answer there. Solving, right? We haven't solved one that's just like this before, but so let's look at it. The reason I'm saying we haven't is because x equals log base 3, 1 over 81, right? So first we're going to change that to an exponent. That's the base, right? This is the quantity. And this is the exponent. Oh yeah, we have solved one just like this before. Okay, so we need to change the 1 over 81 into some power of 3. Because it's 1 over, I know that it's going to be a negative power. And we just have to think, what power would you put on a 3 to turn it into an 81? So that's going to be to the 4th power. Then just set the exponents equal. Okay? Sorry, I was thinking that was in the other spot, but it wasn't. Okay. Okay, here we go. This is what I was looking for. All right? Notice where the x is this time. So we're not going to be looking for an exponent this time. We're going to be looking for a base. So our base is x. Our quantity is 1 over 8. And our exponent is the 3. Okay? So putting those into the right spots, it's x to the 3rd equals 1 over 8. Now again, we don't have to do change of base or any of that unless we're looking for the exponent. All we have to do here is solve the equation. And this one, all we have to do is get rid of that x to the 3rd by taking the 3rd root of both sides. On this side, those two things are opposites, so they just eliminate each other. On this side, I'm going to take the 3rd root of 1 and the 3rd root of 8. Any root of 1 is 1, and the 3rd root of 8 is 2. So your completed answer is 1/2. So depending on where the x is, it'll make your equation easier to solve or a little more difficult to solve. Okay? All right, I'm just going to shift through and look for some things here. Okay, there, we can just change that to the 1/6 power. That's not a big deal. Or to the 1/5 power, I'm sorry. Okay, here's that special case that I was talking to you about that you're not going to like seeing because they look so different, but it's easy. If there's a logarithm in the top and it has, it's in the exponent, then the answer is just whatever number that is. Whatever the quantity is, and that's your answer. okay, every single time. So if you can recognize that one, then it's the easiest one to do. There's no math. Just have to make sure you recognize it. There's another one. So you see the answer is 15, just whatever, because the logarithm is in the exponent. Your exponent is your answer. Solving this one, it's a you're looking for the base, so you're just gonna solve it. Let's see. Looking for the exponent, so that means get the bases the same, set the exponent equal. Let's see. Looking for the quantity, so just going to solve for x after you change it to an exponent. Okay. Now, here we go with the graph. And this is the one where I'm talking about that has a shift. And so what that's going to do is it's going to change the graph somewhat. Because if you have a shift, then it's going to change where the asymptote is, and it's also going to change the look of the graph a little bit. It's going to allow you to have more numbers that you wouldn't be allowed if you didn't have that shift. And remember, we know that it's a shift because we have log base 3 of x plus 2. So remember, when you have that number inside there, that gives you that horizontal shift. But remember, that gives you a horizontal shift at x equals -2. When you pull that 2 away from the x, it changes the sign. So that means that on our graph, we're going to get, at -2, we're going to get our vertical asymptote. Right? Now, also notice that this thing says absolute value of this thing. That tells you that no x's are allowed to be negative if it's an absolute value. And you're going to see when the ones that give you this shift, they're going to do that to you. And so that tells you that your graph, okay, and x plus 2 is obviously bigger than 1, so your x is bigger than 1. So it's going to be doing this business. It's going to be going up, right? If you have an x and you add a 2 to it, it can't be less than 1, right? So it's going to be going up. But what happens is, once it hits 0, because remember it can't go to 0, it's going to go back up on this side, approaching that new asymptote. All right? Now, I don't think it's going to hurt you mathematically. If you don't just choose a bunch of points to do this, if you recognize the shape, I'm fine with that, but you're going to have to recognize the shape. So what happens is it starts doing, and remember, and that's at the y-axis. So just like the last one, it looks like it's behaving, okay, normally by going up on this side, but it bounces off and then goes back up towards that new asymptote. And again, you know it's going to do doing this weird thing because you have that shift. Okay, so if you memorize that shape, right? Now, when you're doing the domain and the range, you remember the domain has changed now. Can't go past -2. So let's look at how they type that in so that you can see. So you see that's the only one that looks like that, going in the right direction. You see the domain now starts at -2. So we've had that horizontal shift that pulled it over a little bit. So usually it's 0. And the range is a hard stop at 0. And again, because of those absolute value bars, it's not that it's approaching 0, it's stop there, dead stop. So that's why you're getting that bracket. Remember your notation. Okay? So that one makes a little bit of a weirder graph, but it's always the same weird graph, by the way, kids. All right. Here we're going to graph this. Log base 4 of x. Okay. Remember, your base is 4, which is bigger than 1, so it's got to do that up thing. So that's B is your only choice that would allow that to happen. So with many of these graphing ones, you can just recognize them. Graph the function using the graphing tool on the. So let's just go through this. This one, they don't give you multiple choice. We have to actually graph it. So let's look at how to graph it. Graph the function y equals log base 3 of x. Okay. So remember when you're graphing it, it's log base 3, right? So we already know, since the base is 3, we already know it's going to be doing this business. We also know that there's no shift because there's no plus or minus, okay? Which means that we're going to get a vertical asymptote there, which means it can approach that, but it can't ever do anything else. So watch what happens when you click on it. Okay, choose the tool palette. We know it's the logarithm tool going up, right? Okay. Now we're going to click on the graph to plot our curve. So I need a point. All right, and I'm pretty sure that we only need 1 point, but let's look at it and see. Getting a point's not any big deal. All we need to do is change it to an exponent, so that becomes 3 to the y equals x. Your easiest points to choose, remember that since the y is in the exponent, choose y points, are 0 and 1, because 3 to the 0 power is 1, and anything to the first power is 3, so we could use 1 and 0, okay, and 3 and 1. So we got 1 and 0, so that means go to the right one, up 0. Oh, I hate this graph because they're counting in 5s, so be very careful. So if that's 0, 0, alright, well, they're going to make us use numbers that they let us make us use. So let's see. Well, once again, my math lab has made your life so much easier that I was doing math and I don't need to, because this is just a plain logarithmic function that we're graphing. There's no shift, there's no absolute value, just a plain logarithmic function looking up. Watch how to graph it. All I need to do is go anywhere on the graph, click, it puts the line in, then it even gives you the base here. If it didn't, you would simply type in the base there, and that would put the line and the points in the correct spot. So you're hoping for some of these on the test. And then vertical shift or horizontal shift, but of course there is none in this case. So all you have to do is click on the graph and it's automatically going to put it in the right spot. Make sure you click save and check your answer just to be sure. There you go. Alright? Oh, sometimes computers make life much easier. Okay? Alright, let's look at the next one. So here, this one we want to change it, and it's product in the top, division in the bottom. So that means an addition, 9, and then 1, and the base of 4, and then subtract z, so d. Right? Just choose the correct one. Sorry for the long pauses. Okay. 8 squared roots of 5, so that's a product, even though it is a radical. But remember that 8 square roots of 5 is the same as saying 8 times 5 raised to the 1/2 power, right? Over 3. So it's going to be log base 4 of 8 plus, remember that power is going to go in front of the word log, log base 5 of 4 of 5, I'm sorry, minus log base 4 of the 3. Okay? So you can't have that radical. You've got to change it. It's got to be exponents when you're talking about logarithms. And so when you do that, you get the exponent of 1/2. And remember, exponents become coefficients in front. Okay? So just bits and pieces. Not difficult, but you've got to be paying attention. And I shouldn't be doing all of your homework for you, but Okay. Now this one's a little different because what we have in the quantity of this particular one is we have 4x plus 3y. This is a product, that's a product, but here's where we have a problem. There is no rule for a sum, right? So if you have any addition or subtraction in your quantity, then you're not going to be able to use one of the rules. The answer is that this cannot be simplified. Okay? And the reason for that is because of that plus. Same thing would happen if you had a minus. You can use those rules to get pluses and minuses, but you can't use the rules with a plus and minus. There's no rule for sum or difference. Okay? Here we have a product in the top, product in the bottom, and a division. Now I want to show you this one because of the division. If you look in the division, there are actually two terms in the bottom. You have a C and a D, and so that's where sometimes the signs can give you a problem. So it's log base 8 of A plus log base 8 of B. That comes from the top. Minus. Now notice I put a parentheses for the front of the minus. That's because there is more than one term in the bottom this time. You really should always do that, but you're not going to. So log base 8 of C minus, plus log base 8 of D. But I have this minus in front of this parentheses. So what that's going to do is it's going to change the sign of the terms inside. It won't affect these at all. Right? Minus a positive becomes negative log base 8 of C. Minus a positive becomes minus log base 8 of D. Okay? I'll just show you the completed answer. Now, of course, it's going to change the numbers, but it'll keep the pieces of the expression the same, so you can see those signs. So you see both of those became a negative at the end. Just changed the base, and it gave us a different problem. Okay? So be careful. If you have two pieces, you've got to subtract them both. Two terms. All right. Getting to the end. I know it's a long assignment, but you're going to have lots of practice with these, and lots of practice with these is what you need, because they're easy. But that doesn't mean that's a dangerous thing. Right? So if you look at this one, log base C of M minus and then a minus, that means that those two things that are being subtracted should be in the bottom, right? So the first one is positive, so that's log base C of M in the top, but the other two, the N and the Z, are in the bottom. Okay? So be careful with those minuses, where the pluses and the minuses are. Okay. All right, here we go. This has some fractions in front. That means that those are exponents. So just put everything in the right spot, and you're good to go. Looks ugly, but it's not. Trust me. And yes, I'm going to make you do it. It's a matter of just staying focused. Okay? All right. Here are some things that we haven't talked about, and that the last couple of problems involve this type of process. And what they've done is they've given you some logs, and they want you to use those properties of logarithms to be able to find the logs without using a calculator. If you know the logs of the pieces, of the factors, then you can find the log of the product. So let me show you what I mean. See, if you have log base 10 of 2, and you have log base 10 of 7, and you want to find log base 10 of 14, if you notice that 14 is the same as 2 times 7, right? So what you really have then is you have the log of a product, which you can find by using that addition part. So all I need to do is take these two numbers here and add them together. So 0.3010 is that first log, right? And the second one is 0.8451. And since it was a product that created that 14 from those two pieces, then you're simply going to add them together. And when you add them together, you'll get your answer. And you round it to 4 decimal places as needed when you put these together. So you're going to see, and again, they're going to change my numbers because I'm going to show completed problem. But you see, all you're doing is getting the same thing as if you just added them together. And again, you're adding because if you took the 2 and the 7 to get a 2 and a 7 to turn into a 14, you're multiplying. So if it's a product, that means you add them. Okay? All right, let's look at the next one. Same kind of process. It's going to go on with these. So if you have two pieces and you know the two pieces, you can put them together to find the bigger one. Okay, here we go. To 4 decimal places, log base 10 of 5 equals that, and log base 10 of 9 equals that. Find the logarithm of log base 10 of 5 over 9 using these values. Do not use a calculator. So you see it's 5 over 9, right? So the way to get a 5 over 9, that's division. So what you're going to do is you're going to take log base 10 of 5 minus log base 10 of 9. And they've already given you those values. You just plug in those values and subtract them, right? And it's subtraction because you're having division there. Okay? So don't make it harder than it is. You're still just using those properties of logarithms. They're just going to want you to plug in some actual numbers and then do the addition and subtraction this time. Last one, same thing, but this time we're also going to have an exponent, because if you look at, so let's go ahead and do this one, because if you look at it, it's log base 10 of 2, log base 10 of 7, and we want to find log base 10 of 4 over 49. So it's division, so there's going to be some subtraction, but notice that 4 is 2 squared, right? So that's 2 squared over 7 squared, right? And remember, that means you have an exponent. That means you're going to have a multiplier of 2. So that's 2 log base 10 of 2. Because it's division, it's minus 2 times log base 10 of 7. So that becomes 2 times the value they give you there, right? Minus 2 times the value they give you there. And then you can do that math. All right? So look at your new base, your new argument, I'm sorry, and then see how you can make that, the 2 that you know, turn into the new one. Not too difficult. Not too shabby. This is one of those where you're doing some manipulations that really make you look like a mathematician. But you're not. You're doing addition, subtraction, multiplication, and division. So you really get to see that some things that look like very complicated mathematics is just a matter of knowing what to do when. Keep that in mind as you go. If you know what to do when, you are in good shape. Okay, we're going to solve some more logarithmic equations to finish this out. We've got 2 more sections to go. They're both fairly short, and so we'll talk about those next time. Thanks, guys.